Limpet Adaptations No trespassing of the species. Lotia gigantea is one which marks its territory. It aggressively pushes other organisms out of its area by crushing them with its shell, thus preserving its patch of algae for its own feeding. Limpets are marine creatures which belong to the phylum Mollusca and class Gastropodea. They are mainly found within the mid-intertidal, intertidal and subtidal zones of seashores. The structure of limpet is same as other mollusks. They have three distinct regions: the head foot which facilitates locomotion and sensory reception, the visceral mass comprising the digestive, circulatory, excretory and reproductive systems, and the mantle surrounding the visceral mass. They have flattened, conical or cap-shaped shells that can be smooth or radially ribbed. The shells of limpets are generally white-pink, grey, dark brown or green with a yellow tint at times. Some of them also have white spots and radial rays. The inner side of the foot is yellow, dull orange or brown and with green or grey shades. The mantle is fringed with tentacles internal to which lies the pallial gills. There are various groups of limpets that come from various ancestral gastropods. True limpets are marine limpets that belong to the order Patelogastropodea, subclass Eogastropoda. Besides this, the term limpet is also used for various types of snails in the subclass Orthogastropoda. They include the marine limpets like keyhole limpets, family Fissurilidae, the slipper limpets, family Calyptrade, the hoof limpets, family Hypnix, limpets like Tylodina and Umbraculum, and the pulmonate false limpets, family Siphonaria. Adaptations foot. There are two important adaptations that protect true limpets. One is the physical defense of the shell. Another is the adhering strength of the foot that protects limpets against the forces of waves and attack by predators such as shore birds, fish, small mammals, seals, and humans. There are two ways in which the foot attachment works. One is the suction, which enables limpets to strongly attach to the rocks with no restriction on movement. The foot adheres as well slides across a smooth surface. However, when limpets move across holes or uneven surfaces, their foot becomes susceptible to leaks. The other method of attachment is glue-like adhesion. Here the foot attaches to the surface with the help of a sticky foot mucus. This mode provides greater resistance to forces, and there are no chances of leaks as well. Shells. The cup-shaped shells of limpets is an adaptation that enables them to thrive on higher rocks and near the sea. Limpets living near the water have flatter and smaller shells so that the forces of waves cannot beat against them and pull them away. Those thriving in higher rocks have higher and wider shells. They are at a higher risk of destruction due to less frequent contact with water, sunlight, water evaporation, and the winds. Their tight grip to the rock with the help of their foot enables them to trap some water inside their shell and prevent themselves from drying out. They also secrete chemicals that promote the growth of the shell. Lungs. As an adaptation to breathing, almost all marine limpets possess gills. While all the freshwater limpets and a few marine limpets possess a mantle cavity that serves as a lung. The keyhole limpets have a hole at the top of their shells through which water is expelled out after it is drawn in from the base of the shell. Camouflage. The shells of limpets differ in appearance and may change color from time to time. Their shells have colors that look like the surfaces of rocks they inhabit, which provide camouflage and protection. Many limpets are often covered in green marine algae, which makes it difficult to recognize them. Teeth and tongue. Limpets feed on a variety of things depending upon their habitat. Varied species of limpets possess structurally different teeth that function as scraping tools. True limpets scrape off and feed on algal spores and bits of plant matter from the rocks. They do this with the radula, which is a ribbon-like tongue with many teeth, at least 12 in each row. Equal size blunt, radular teeth are present in limpets that feed on coral lineage. Limpets that feed on rock substrates have unequal-sized, sharp teeth. Limpets that feed on marine angiosperms have broad and flat-topped teeth. There are also certain smaller species of true limpets that live on sea grasses and graze on the microscopic algae that grow there. Some other species live and feed on the stalk of brown algae. The keyhole and slit limpets are usually carnivorous and feed on sponges, corals, and other sessile animals. Locomotion limpets move with the help of their broad, flat, muscular foot. This is achieved by deforming their body so that small transverse waves travel along their foot from back to front, thereby enabling them to move forward. Behavior when deluged by water during high tides, they move into the sea and then come back to the same spot. It is still not clear how limpets return to the same spot every time, but it is believed that they leave a mucus trail along its path and follow it to come to the spot. This spot forms scratches engraved by the edges of their shells, which enables a limpet to form a better home scar. Limpets reproduce through a behavior called spawning. It happens once a year, usually during winter. Several females release eggs and males release sperm into the water, where the eggs fertilize. Some species of limpets are known to undergo sex change from male to female. They are initially males and change to females after attaining a certain size. Limpets have been a food source for humans since early times. They are also used in artwork and as jewelry. Also, it has been found that limpets have very strong teeth, even stronger than spider silk due to the protein structure strengthened by nanofibers of a mineral called goethite. So, performance engineers are thinking about creating better and more robust vehicles like bicycles, boats, and race cars out of limpet teeth in the near future.